we are seeing intense volatility in global energy markets. Does this geopolitical turmoil make your circular solution more attractive, or are investors still prioritizing short term price stability?
Oh man, you're asking all the right questions today on this. I'll tell you.
Hello, everyone. Welcome to another episode of Interviews with Experts. Today, we have Ofer Vicus, CEO of Aduro Clean Tech, a pioneer in waste plastic recycling. Ofer, welcome to the show.
Thank you for having me, CEO and co-founder, I'll say.
Thank you. So, Ofer, we have often told that innovation is a eureka moment, but your story seems to be one of endurance. Nearly 15 years in the lab before stepping into the spotlight. So, before we
Yeah.
talk about the future, take us back to your pre-Aduro life, in your previous stints, previous companies. What was the specific professional itch you couldn't scratch in those corporate roles that ultimately drove you to walk away and co-found Aduro in 2011?
Wow. That is over almost 20 years from now. Basically, I'm an industrial. My name is Ofer. I'm the co-founder, and thank you for having me, and thank you for the audience here that take the time to listen to the things we do. So I am basically an industrial engineer by background with some master with business. And I was for half of, the initial part of my life worked in the communication sector and later gradually moved into the energy sector where I guess we stayed. For most of the time, I was, I guess, maybe closer to the business development side of things. And I, was keen on my end to do good as much as I can in my workload. But I founded this concept or this idea, which I remember reading even when I was younger, believe
Okay.
it or not, at 16 years old.
Okay.
And I met the guy that discussed this idea or this phenomena sometimes in Toronto in 2009. And this is where the journey started. I remember reading about that phenomena and I was intrigued. And from that moment, I just started to build information to understand. It intrigued me at the beginning intellectually, and then it intrigued me from the sheer size of it. And I'll explain immediately. Anyone who's working in the hydrocarbon space
Okay.
knows that, thousands of barrels of material are moving in a pipeline. So that is a big market, whatever,
Right.
however you look at it. And not being at the time, I was already in the energy sector, and being aware of the large, massive organization that all around us, maybe some of them are already 70 or 100 years old, and none of them somewhat identified that phenomena. That kept me really, really intrigued. I thought it
Okay.
impossible that I will be the one. And so the journey of Aduro started in 2011, where I called in 2009, I showed it to him, but in 2011, we incorporated Aduro and we
Okay.
started the journey of investigating that phenomena.
Right. Right. So you have spent years in that pre-revenue phase, essentially in
Yes.
research, stealth mode. So what
Yeah.
kept the mission alive during those years when you had no website, no social footprint, and weren't even on the industry radar?
Yeah, I think it was the intellectual curiosity that and belief at some point of time very early. So we did our research before we even incorporated the company from 2009 to 2011. And that research meant that I've investigated why that phenomena is so unique and why others have not come across it. And that curiosity led to understanding, if you're right, this is a very rare moment for me and for everyone else, but it's also represent a massive market. At the time, we were only thinking about heavy oil. At the time, I think Canada was producing about 2.5 million barrels every day of heavy
Okay.
oil. And the sheer thought that we could help and create that oil lighter, that means reduce a little bit of the cost, is enormous, both intellectually and financially. And I think that was the driven behind it.
Let's talk about technology. Most chemical recycling is energy intensive, high heat pyrolysis. How
Yes.
does HCT use water as a chemical sealer to bypass those thermal limits?
Yeah, I mean, I guess the basic, if you will, for your audience, the basic, the initial maybe background is that if you're talking about pyrolysis, for example, if you take pyrolysis as an example, you're talking about a very defined moment where you're heating molecules until basically they explode, right?
Right.
They expand and they break down, and there is penalties around that. But if I can think of pyrolysis as maybe an approach, the concept, the direction of what it's been doing, you know it at the end, with catalyst, without catalyst, however you look at it, you know it at the end, you would use heat, whether it's water-based or whether it's just heat-based. It doesn't matter. You would use a lot of energy to break down and crack the molecules, and then you have to deal with everything else, polymerization and things of such. If you think of the HCT, I recommend to think of HCT as a bundle of ratios. It's not specifically an element, a defined element. It is the interplay ratio between pressure, temperature, catalyst. It is that relationship that allows us to motivate the bond scissioning to a very specific direction. And so the HCT basically is a compound of maybe three phenomena that you will all recognize. Well, first of all, we found out that the catalyst is really doing very selective carbon-carbon bond breaking, and that's happening, and it's really, really selective. So, what we've seen immediately that this thing is breaking down in a nicely way. And I'm talking for now just about heavy oil. Later we can go to plastic recycling. And then through that bond scissioning, we found out that just with the help of catalysts, that if you would have maybe some element such as a glycerol around. The glycerol is breaking down in situ in the system, and then when you are working through the process, there is an element of quenching into it, because those radicals are connected all together, and in that area, and with let's say with the environment of water, there is also a little bit of aqueous form reforming, right? And so those are elements that you all recognize, but in a specific environment like the HCT, those things are happening apparently in situ. And when it happens in situ, it's basically stop the continuation, or the continuation of the bad chemistry that could happen, like polymerization and everything around that. And so we found that phenomenon and identified to be quite unique, because it's an interplay between pressure, temperature, water that needs to be there. And by the way, we're not using a lot of water. If you heard of companies that are using water as a mechanism to crack molecules, just the heat and the sheer heat, in the environment of water, that means they're using much more a pyrolysis approach than what we're using. But if you lock down to the catalyst, and then you do some bond scissioning, and then you are creating, your aqueous reforming, and then the quenching that is inside, then you stabilize this environment in situ, and that is the core. And so the net result is that you're getting, let's say, breakup of carbon chains anywhere between, I'll say, C5 to C, for the majority of it, to C20. You have a little bit that goes on to larger numbers. But by the way, if you really want, you can bring those back to the system and break them again, right? Like it's, and that's the I guess the cycle that is happening. We're not using a lot of water. We're not using a lot of materials, such as a glycerol, which is breaking down in our system, and we're not using a lot of catalyst. All of those elements are pretty cheap. The catalyst is super cheap. It's unique, but it's very, very super cheap. And so now you have a system that is, very cheap and very effective. And to tell you the truth, one more element for the audience that, maybe are more chemically averse, in heavy oil, the catalyst is basically used to be the metal that are already available in heavy oil. And that was part of a big secret for Aduro for many, many years. Should heavy oil companies knew that all they need to do is, rather than motivate them to reduce metal concentration in the heavy oil, we actually increase metal concentration in the environment of water and heat and temperature to start the initial phase of breaking those bond scissioning or creating that bond scissioning.
Right, right. For the industry is notoriously, skeptical of dirty feedstocks. How do you convince a refinery that your HCT process can handle the messy reality of mixed plastic waste?
Yeah, so I will start and tell you that first and foremost, based on my, humble knowledge, there's no free lunch. You put garbage in, you get garbage out. There is so many competing chemistries that's happening around that you do need to do some cleanup. And if anyone think, no, I just gonna take this bucket of dog food and dog bones and chicken and whatever it is, and I'll just mix it with some chemical materials such as waste plastic or whatever, whatever family and something good will happen with it. I say, yeah, this is not going to happen. And when you think of refinery in general, think what happened. Basically, you punch a hole in the ground, you take some material that is very, very unified. It's a mix of something, but it's normally very, very unified. You go through a process, and there is a lot of the same material, and you come into, you run it through the process of distillation and, maybe cracking after that and separation, everything around. But the material is quite unified. What's unified in waste plastic that is happening? This is the opposite of unified. And so what we found out is that beyond, yes, you would need certain level of cleaning, but basically a lot of the elements that are in the waste plastic basically are not hurting the chemistry. The chemistry can undergo or tolerate a little bit higher level of contamination to start with, just as a general idea. Basically, we're only operating on maybe the three families that polyethylene, polypropylene, polystyrene, PET, and the PVC, and the rest of the families are not participating in this. In fact, we consider them to be at the contaminated mode, and if they go beyond several percentage, you want to get rid of them first before it comes out. Last thing is basically, I think what you need to look at the core of it is the performance of the process, and at the end of it, the performance of the process takes the yield of it is higher. So if you one by one, we're producing more liquid oil that could be recycled, could be then participate in the circularity, and compared to competing technologies such as pyrolysis, because a lot of what actually pyrolysis is producing is petroleum product, a diesel-like and gas-like and things like that, which we try to avoid and minimize it. And second, so we're able to process more material to waste plastic and to oil. But second, it does not need hydrogenation. There is already in situ high saturation that is occurring, and for that reason, you're saving some money in the hydrogenation phase. And so you have a system with a very light, easy catalyst that is actually operating on a little bit higher tolerance of contamination, that is using very simple, effective materials such as water, glycerol, and the material inside using in an environment where you're producing, at the end of it, the net result of it is more oil that could be, appropriate at the range of, let's say, C5 to C20. It's very much appropriate to a naphtha cracker. And so altogether, it's a high performance chip system to do what we do.
Okay. Okay. So, are there any specific contaminants, that you have found actually improve the process? So, or is the goal always to get as close as virgin like feedstock or as possible?
Yeah, so, PET, when you break PET down, then we break down with water and the ethyl glycol is there. And if you're using glycerol or ethanol, then we could use also ethyl glycol to do a little bit of what we're doing. But that is part of the process. We're not very much afraid of PET, but we need to be, aware of the level of it because we don't want too much of it. Too much of it is worthy of just cleaning it and making, putting it maybe in a way you can collect it and create value of it. There's no point of, because other than that, it's not doing anything else to the system. I would say that if anything, I would look at the process, at the HEC process, as one that is just having a little bit more tolerance to the general contamination level. That's all basically in the perspective of your question.
Hmm. Understood. Yeah. The term drop-in is a buzzword in energy. Why is that Aduro's output is uniquely compatible with existing petrochemical infrastructure without any massive upgrades?
Right. So because the output that we're producing is already saturated to a certain level, and it does not need any hydrogenation, basically. And so naphtha cracker, which is basically the end customer of our oil, before you put it, is very sensitive machine, and every pie oil that brought into the system had to be hydrogenated one way or the other, and there's capital costs associated with that, and those machines are very, very sensitive. And being able to overcome that step is quite unique in the system and in the market. And so at the end of the day, it's a cheap setup to achieve so much in what as a refinery process that existing for almost 100 years.
Right. Right. Now, for a CEO of a traditional refinery, what is the biggest technical hurdle they usually cite when you tell them you can plug your output into their existing lines?
Yes. So the first thing that they say, yeah, I heard it again, and that's the first moment. And just come back when you have a pilot. So we have developed a very, and that's true, by the way. They heard it again. This is a very veteran industry, right? I think pyrolysis is out there for almost 100 years. And
Right.
the chemical process is almost about, the refining process is about 200 years. So, every other day, somebody crazy coming in to tell them, I got something that you never heard. And I'll help you in your process that is working and you're happy with it. And all we need is just use my equipment and everything will be fine. You trust me on this. And so I think what's unique in our end is as soon as we understood that phenomena is unique. And
Right.
soon we understood that there is high skeptic in the market because they are very careful. Nobody wants anything to blow up in their petrochemical plant. We took a strategic path to do two things. We basically decided on the business model that will be built on operate and licensing. So the licensing concept wasn't easy, and you basically prove the concept and then interested organization will come, and you can't normally do it by yourself. There is a lot that goes into it in terms of performance, warranty or guarantee. So you need a lot of organization. But the build on operate is your initial setup. So I committed the company to, first of all, build our own unit, an industrial unit that not just will demonstrate what we're doing, but understanding and recognizing that licensing may take some time. I
Right.
wanted to generate some revenue and de-risk the future of the company, basically. And so
Right.
we always told investors that we're going to do both, and whatever comes first, great. And what we've seen later is that, of course, we put our money in where our mouth is. We start investing where we feel we'll build our own site, and we have a site now in Holland, where actually we're building it to be a fully industrial site. And so what happened is that organization that thought, oh, now I need to invest in R&D and I need to see
Right.
how is it going, had
Right.
an easier life. On the other hand, I have never, knowing that phenomena is quite unique, we have never run too hard after, believe it or not, after petrochemical organization. We knew that we need to give them the time to understand the technology. And I can tell you, my goal from the first day, I went back to the R&D and I asked them, who's going to pay for that? And so and I knew this is so unique that the petrochemical organization would need some time. So we created a program called customer engagement. And
Okay.
already when we have 5 milligram vials, nothing, a 300 mil reactor, I invited a petrochemical organization to see what we've been doing. And so just to give them the time to understand. And I can tell you that in several cases, we've been selected over, organization that have been
Okay.
tested or looked in 100, 400 companies. So build and operate, first of all, licensing as a secondary, give them
Right.
the time to adjust. And that's what, happened. This is how the ball start rolling.
Hmm. Right. Right. You have expanded HCT applications into paraffinic crudes.
Yes.
So is this a pivot to help big oil companies, decarbonize their existing assets, or a play to dominate the new materials supply chain?
It's a great question. So, I mean, I'll share with you my belief on this. That first of all, yes, Aduro has maybe two branches. One would be what we call treating unconventional, upgrading unconventional crude. I'll put in unconventional crude, upgrading of heavy oil to a lighter oil, and yes, dealing with the paraffinic crude and taking the wax out of it and maybe make it a little bit more conventional. And there's this thing unique about paraffinic crude that we will talk. But then we have, of course, the chemical recycling aspect and maybe other application related to the more sustainable or environmental play, such as dealing with maybe renewable oil to renewable crude, and maybe even dealing later with waste rubber. But if I'll take paraffinic crude as it stands alone,
Right.
um, our output is basically paraffinic oil from chemical recycling. And paraffinic crude, just by the name, you would know that it's very, very resemble. And so for us, it was basically liquid plastic. It was just an extension of the know-how that we have developed for chemical recycling, for plastic recycling. And so it wasn't very hard. And paraffinic crude, by the way, when it comes to from the ground, it is hot and it's
Okay.
liquid. It's moving around. And so just by definition, oh, I need half of my system because I don't need extruders and anything around to take solid and melt them. And I'm working on already material that has certain carbon chain. All I need to do is cut it down a little bit. So it was so natural, for us. Now, when it comes to the market, there's a lot of it. I think about 20%. That's what the report says all over the world. But we believe there is a really good opportunities in the United States for different reasons. Well, first of all, maybe if you know that the current regime or the current, I guess, management in the United States are very much fond of energy independence,
Right.
right?
Right.
And
Yes.
and the way we see it, United States, I think the records suggest maybe 11 or 12 million barrels of oil every day that they are consuming. And
Mhm.
so paraffinic crude is very small play. It's only 170, 180,000 barrels a day in Utah, specifically in Utah.
Okay.
And so we believe that we have a play there to increase that volume because we're making that crude pipelineable. And
Okay.
so we
Okay.
feel that specifically in the United States, there is a very interesting scenario where the whole world is looking for energy independence. Specifically, there is a resource that, was limited, actual limited, and challenged because it was wax. In order to deal with the paraffinic crude, you need heated tanks. You needed
Right.
the trucks that are blankets to restore the heat. You needed the trains that able to go on a platform to steam heated them. There is a lot of challenges in the transportation of that things. So if you take that away and you suddenly are able to extend the market of the crude, because now it's no longer limited by its characterization, it becomes closer to conventional crude. And that means you can sell it to any refinery across North America, basically. So this is what we see holistically on the bigger picture. But
Right.
we need one small step. And so the first step right now is to build what we call the technology demonstration, which we are already have it up in the shop. And at some point of time, we'll show and demonstrate continuous run of upgrading of paraffinic crude, actually.
Right. Right. So, offer, we are seeing intense volatility in global energy markets. Does this geopolitical turmoil make your circular solution more attractive, or are investors still prioritizing short-term price stability?
Oh man, you're asking all the right questions today on this. So I'll tell you, I've seen over the time in my years, investor CEOs making promises that are really really hard to fulfill, and
Right.
I've decided not to take that path. I've decided to
Okay.
break down my yearly activity to two, three activities that investors will see every year. And that activity will do one of the following: de-risk the company, create some opportunity to the company, or maybe advance the company. So
Okay.
if I'll go back maybe 2 years ago, 3 years ago, I said to the investors, this year we'll build a technology demonstration. This year we'll do some more patent. This year we'll maybe bring a deal. So
Mhm.
investors will be able to see the performance of the execution of what we've been doing. Over time, we generate credit. From the day we become public, and I invited your team to look at our chart,
Mhm.
basically that was the philosophy of action. So there was never a promise to do $100 million deal. There was just a
Right.
reality to do a gradual progress. So
Mhm.
by
Mhm.
definition, investors that were looking for maybe the 20 to 30 cents, a dollar to $2 flip, was not really fond of what we've been doing. The play was more to the long-term investors. And
Right.
here you really had to not mess it up. You really had to meet your milestones every year. And that's what we've
Exactly.
been doing. So
Right.
we feel we are a play for long-term investors. We're a play that, there's a lot of catalysts. This market is huge. We have more than, I think, over $200 billion in addressable market. It's huge. How much
Right.
more do you want? And so we just need to move gradually towards the goal, knowing that this is not a done deal. I cannot promise you today that everything will be fine in a year or in 2 years' time. You will never hear it from me. It is a new phenomena. It was never investigated before. We are the first to produce it.
Mhm.
Guys who wants to use some risk, should look at that, but also do your due diligence, see if what we're doing seems to be in your ballpark of interest, and then decide how you evaluate us. And what we feel right now today, we have a very loyal shareholders that have been moved with us. I tell you, some of them as early as 2012. And
Okay. Okay.
yeah, and we have retail investors since the day we become public, probably about 30 or 40% of them coming back and increasing their position since that day. And if you look at the chart, I think that represent not just the loyalty or what we've been doing, but also on the other hand, the execution, the level of execution. So it's almost like working in partnership with the
Right.
investors.
Right. 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 So, are you finding this, energy independence is now a more powerful sales pitch than going green?
Um, with respect to what's going on geopolitically, and I think there is a good thing, a lot of good things that happens because in our favor, because every, if you will, territory is looking for localized solution, which makes sense. And when you think of chemical recycling as plastic recycling, our feeling is that Europe that thoughts, basically initially Europe thoughts about recycling from the way we understand it, from two areas. The first one, just, the sustainability concept. Europe doesn't want anymore to deal with waste plastic the way they were dealing in many years. But there was another element which was somehow protecting the chemical industry from foreigner cheap material coming in. So, making a statement that you need to do some, let's say, 5 or 10 or 30% of your every plastic product should be, content with some level of circularity, means that you cannot just buy cheap product and just sell as much as plastic as you want. You have to mix it with local waste. But now we're identifying another element for Europe, for example, where they see part of the circularity as, the circularity area is part of energy independence. And this is a new concept that came only from the recent global movement. So yes, the net result is that I think it's operating in our favor. And I should say, even if it wasn't, it's still, in the energy play, when you're taking or saving some money from, if you're taking unconventional crude and you save some money in the process of upgrading it to conventional crude, it helps in the cost. So regardless, but the current situation is quite helpful for the company, I believe, and I don't see that changing in the near future, as we all see all around us.
Right. Let's talk about Europe. What does Europe understand about the circular mandate that North America is perhaps still missing?
So this is if you will, was a good initiative at the beginning, and I think now it's been tested. Actually, I think from what we see for the elements that I mentioned, Europe actually will see it through, and it may be taking as a case study for the rest of the world. So dealing with circular material is basically investing already, by collecting. It's a negative investment element right there. When you start collecting waste plastic, you have to invest resources in collect material. You have to invest resources in wash it. You have to invest resources in clean it and separate and prepare it. There's a lot of money comes in before you even start dealing with it. And plastic is very, very cheap. So what we feel basically that Euro set the boundaries and says you're no longer allowed to ship it somewhere. You're no longer allowed to get rid of it or to bury it. You have to do something with it, which effectively created a market. So we don't ask from the government for so much, but if the government is doing some regulations in it, then my belief is that the market will sort itself. And what happened right now in Europe is that there was, I call it maybe a hangover from pyrolysis. So basically some of the regulation that Europe is not accepting fuel, there's a fuel exam from the oil that you're producing. So pyrolysis, for example, is very, very much challenged because if X amount of material of the py oil is considered to be fuel and not considered to be circular naphtha, it does exempt and it doesn't get credit. And so the technology itself, the approach itself is being challenged by performance. So you have a technology that, a lot of the output is not considered and already need hydrogenation. And so I think today in Europe, there is a little bit of a hangover, understanding of what pyrolysis can do. And there is a little bit of a search for different technologies that are actually able to meet that. I see Aduro as definitely a contender to do that. But I also see that the European market was a little bit delaying in pushing the regulation in. And for that reason, many organizations has been challenged over the recent years. What we see right now is a firm action from the European side, and they're saying that by 2030, some of those regulations will come into effect. And if you're not ready, that is your problem, which is for us a very good sign, because we feel there could be a perfect storm there, for companies like us our ability to grow, the process, the HCT process, it's not very hard to build it. It takes us about maybe 12 months to build a process that is at the size of 20 to 30,000 barrels per day. It contains of three elements: extruders, chemical, the reactors, and maybe the recovery system. Most of them are off-the-shelf product. So if you need 100,000 or 200,000 or 300,000, I'll just buy several units of the same. It won't take me so much to produce a growth. And so we think we want to be ready by 2028 with the process that is up and running, but we want to be able to produce between 2028 and 2030 and 2031 or 32 or 33 growth production or growth per capacity to meet that demand. So we feel the European right now are coming into the regulation in a good, favorable way for us.
Okay. Okay. You know, you have navigated the transition from a private R&D to a public company.
Yes.
How
I don't
has
recommend it to anyone. No, don't do that. It's very hard.
it's it's hard, I know, you know, but how has that changed the tempo of your decision making?
Oh my God. I'll give you the right example. At the end of when we did an RTO, so reverse takeover, and it took me just by comparable, from 2011, let's say, until the day we become a year or 2 years before we become public, it was really, really hard to raise money. And I raised my first $500,000 knowing that I'm going to the market within maybe an hour or 20 minutes of a conversation among several investors that had a shell company that we did the reverse takeover. However, the moment I got some money and I got some investors coming in and the company was launching to become a public company, I just wanted to focus on work. I knew nothing about the public market as I know it today, and
Right.
and we've been always working, as you mentioned. There was no social footprint of Aduro. There was no
Right.
website. Everything was in the dark. Initially, we didn't have the money, and later we just did not want to do it. And so I got a phone call about 48 hours before we were launching from our main family investor. He says, Ofer, where's your website? And I said, nah, don't worry about it. We're going to work.
Right.
And he says, what? And I said, no, I'm not doing website. I'm just going to work. I got my money. Everything is fine. And I got a kick in the teeth immediately and says, Ofer, just go do your website and it needs to be ready within 48 hours. So a very different tempo from your being private to much more open, much more vocal,
Right.
much more aggressive on the level of reporting, all of which needs to make sense, all of which needs to be honest to a certain level and accurate to a certain level. All you have is your word. Your word is your bond. People invest
Right.
in the people, and if you don't understand that, you have a big problem in the public market. After that, it's really becoming an issue because you'll be burned, and the company will be burned. Nobody will touch it. So very, very different reality between the private and the public.
Very, very interesting, you know. Ofer, correct me if I'm wrong, you know, you have a deep background in safety culture and industrial compliance. How does that corporate history influence the way you manage a high-speed, innovative tech startup?
Yeah. So to say that event doesn't happen would be a pure lie. It's the question: how do you manage it? How much resources you put in it, and what are you willing to do? From yourself to make sure that people will go home safely and healthy. And so. For us as a company, as a person, first and foremost, our job is hard. What we do in the company is hard. And dealing with the hydrocarbons day in and day out is not an easy thing. It smells, you
Right.
can breathe it if you don't, realize that if we're using reactors at high temperature and high pressure, so those are little bombs. So if you're not integrating that reality, that actually that on top of everything else, if something doesn't smell or feel in the right way, it's better to postpone and rethink it than do it. That reality. And another element
Right.
there is that I have made, and that's my nature in many ways, no shortage of investment in putting safety procedures in place. So
Okay.
the most expensive HVAC system that we could put, the most elements in the lab that are intrinsically safe and reduced, things related to just there was no shortage. I don't remember ever telling the team we don't have money to build safety. Everything needs to be beyond the code. And internally, above of everything, none of it is important if you don't build the culture around it. So people needs to
Right.
believe the
Right.
first and foremost that they walk from the door back. It's just a simple place to work, and they're going back home safe. And if you don't, if you don't get that, you're already in trouble because things will happen, and they happen when you're not expected that. And so, you have to integrate that in your philosophy, basically.
So, for the next generation of founders looking at the climate crisis, what is the
Mhm.
one piece of advice you'd give them about the reality of commercializing deep tech?
I'm very fond of science-based equipment. I'm very fond of simple characteristic that basically create value. So and there is plenty of people that are impatient and they want to see things running quickly and fastly. I don't blame them, and I understand that. It wasn't my journey. I found out that there's no free lunch,
Right.
definitely in chemistry. And I haven't seen, and I can tell you as when I'm looking outside, it's hard to find rare moments. So you have to go back to the science level, and you have to be maybe lucky or enough around a scientific environment in order to see, for me, real things that are making a difference. And if you keep it simple, and you'll find, what value or the gap that you recognize it. You do need some luck, but then everything that I, overgone. So be honest about it, be transparent
Right.
about it, be very um, determined about it. Those are the things, and never think, in my view, of tomorrow or the day after. I always believe that Aduro could become a large organization beyond the billions of dollars. And when we build the foundation of the company, right there, I already thought about it in that level. And that is the type of vision that I think one need in order to be able to cross that very, very challenging times.
Hmm. Right.
I,
So, offer.
Also to say that there is no free lunch here. They have to work really hard. I don't know if if they haven't got it. It's really, yeah,
They have to, yes. So,
yes,
offer, we have dissected everything from molecular seizures to global energy grids. So, before we let you go, I want
for
to ask,
sure.
the world is drowning in materials we call waste. So if you could convince every industrial leader listening today to change one single assumption about their supply chain, what would it be?
That's a very, very challenging question on industries that I don't recognize. I had a discussion actually when funny you say that on Sunday I was actually filming a video, and I had a discussion with an organization. I won't say the name because it's not public yet. That we are maybe doing producing synthetic turf, and they're working
Okay.
in North America. And in North America, the regulation is not there. And for us to work in North America, and this is not the only discussion that I have with related plastic manufacturer. I had a similar discussion with an organization that's one of the leading manufacturer of plastic product, for Canadian Tires and Walmart and others. And what I
Okay.
found out is that you really want to make a change. If because you have to work through the process to understand where is the gap and where is the economic value. Without
Mhm.
economic value, it's really hard to do it. But you would have to really want to make a change in order to create. And so I think for everyone around us that are doing what we've been doing, one way or the other, in the metal recycling, in the plastic recycling, maybe in recovery or other elements, you really want to find a gap, or you want to look for it, and it will not present itself immediately as offtake money making. If it was so easy, everyone would do it.
Exactly. Yes. Yes. So a compelling vision for a more circular tomorrow. Ofer Vicus, thank you for the insights and for joining
Thank
us
you
on
very
today's
much.
session. Thank you very much.
Thank you very much for having me, and thank you for the audience that taking the time to listen to us.
Thank you.